attending K-Flex USA's webinar on the benefits of using elastomeric foam insulation for supermarket applications. We're going to have a brief introduction to the company of K-Flex USA. Then we're going to review some insulation benefits and basics. And we're going to go into further depth on insulation system design. First, we're going to hit upon the major points that drive the design. We're going to key into the important spec points that want to be addressed in every insulation specification. And we'll be going into installation best practices. And we'll close this webinar by discussing some of the K-Flex products and how they can add value-added services that they can to your specification and to your jobs. Welcome to K-Flex USA, which is part of the Isolante K-Flex Insulation Group. K-Flex is headquartered in Milan, Italy, and has 12 production facilities in 8 different countries, and distribution in 43 different countries. K is headquartered in Youngsville, North Carolina, which is right outside of Raleigh, and is the manufacturing point for all North American products. Company information. This line shows that while K-Flex USA was started in North America approximately 15 years ago, it has a much longer history than that through a series of mergers and acquisitions. As in the mid-60s and 70s, companies like Rubitex and Halstead were formed. Through these mergers and acquisitions, K-Flex has acquired both the product and the rights to those products. So while having only been around in its current form for the past 15 years, it goes back much further to the beginning of the rubber insulation industry in North America. The description of the major K-Flex USA products are that they are a closed-cell, flexible elastomeric foam for thermal and acoustic insulation. The 3 main ingredients, first being an NBR, which is nitrile butadiene rubber, PVC blend. The second are environmentally safe fillers, flame retardants, and additives, all of which are CFC, HCFC, and PBDE free. Finally, all of our products include an EPA-registered antimicrobial agent to prevent any type of mold or fungal growth. Use these material into tubes, sheets, and fittings of different diameters and thicknesses, up to 2 inches thick. And applications that they can be installed on include pipes and vessels within the minus 297 Fahrenheit to the plus 220 Fahrenheit temperature range. Let's bring over the production process for our standard materials. In the top left picture, this is all final batch. This is dense rubber sheets. Include the PVC and NBR and all of our fillers and antimicrobial agents. Loaded into the extrusion process. Top right picture, you see six heading head. This changes out depending on the size, the ID, and the thickness of the product that we're running that today. Extruded into a continuous 220-foot long 7-stage oven where it's baked into the form that you're familiar with. And from goes into our cutting and packaging lines, all of which are automated, and from there to our warehouses for distribution across the country. Just we're going to go over some insulation system benefits. So in a fully designed insulation system with proper material, thickness, installation, and maintenance, we're going to energy savings, condensation control, and freeze protection. These are 3 things that we're very aware of and that we look for in every insulation specification. But something that we may not think of with an insulation system include equipment performance, reduction, health safety from both hot and cold burns, meaning if we put 40-degree fluid in one end of a pipe, we generally want 40-degree fluid to come out of the other end, and a proper insulation system will help with that, and fire protection. Soup applications are unique due to the amount of refrigeration generally found in those stores. But in addition to the refrigeration lines, it's important to remember that other insulation applications in a supermarket also include the plumbing, both hot and cold domestic water, the HVAC equipment, and EM equipment such as ice makers, chillers, water coolers, and things of that nature. To focus mostly on the refrigeration segment of the supermarkets because they're the most prevalent with mechanical insulation. But everything that we discussed today can be applied to the other areas I just mentioned. lines. Some of the application considerations specific to those are the following. The first thing I want to keep in mind is the operation temperature ranges for your typical refrigeration lines, and they generally range between -40 Fahrenheit to +35 and can fill up to 80 degrees Fahrenheit for hot gas defrost. You'll keep in mind that they are in continuous operation, sometimes in unconditioned spaces, which is generally a unidirectional vapor drive. Drive is when a high level of moisture vapor pressure in the ambient air is to get to the lower pressure air surrounding the insulated pipe surface. That cold pipe surface is what causes that low pressure air, and the insulation system is what's preventing moisture-laden high pressure air from hitting that cold pipe surface and condensing. Key insulation properties are thermoconductivity and water permeability, both of which I'll discuss here on the next slide. So these two most important terms that we'll discuss today in regards to an insulation system. This review, most of you probably know this already, but thermal conductivity is a material property that measures the ability to conduct heat, also known as the K value. The unit measure is BTU inch per hour foot squared degree Fahrenheit. Note that the lower the K value, the higher the insulating value. So this is the inverse value. With R values, when it comes to insulation, generally the higher the R value, the better an insulator it is. K value is the inverse, so the lower the better for this particular property. It's important to remember that it's not a constant. It does vary with the temperature at which it is measured. Standard insulation products are generally measured at 75 degrees Fahrenheit, but when comparing two products, it's important to note and make sure that you're comparing apples to apples, and that you're comparing K values both measured at the same temperature range. And then the K range for most insulation materials is a 0.23 to 0.31. It's important to remember this because the thermal K of other materials, such as water, can be upwards of 16, copper upwards of 250, and steel upwards of 300. At a certain point, materials stop being considered insulators and become conductors. And we'll talk about more about that in a slide or two. Now, the second most important we'll discuss today is water vapor permeability, which measures the material's ability to resist penetration of moisture from the air. Its unit is perms inch, and the resistance to moisture intrusion, the greater consistency of performance over time. Basically meaning wet insulation systems don't work very well. So if we can keep them dry and maintain them dry over the life cycle of the insulation system, you'll have consistent performance of that system over the life cycle of the insulation product. This shows exactly what I just mentioned, that a wet insulation system is not going to work as well as a dry insulation system. You can see here, the chart to the right and the graph to the left show insulation systems with various water permeabilities on day one. The solid black line dictates an insulation system that has a permeability of 0.01 perm inches on day one, and shows that since it's such a low permeability material, it will not hold and acquire moisture over the next 10 years, which means that the thermal K that you get at day one, which is about a 0.25, will maintain over the course of the 10 years and really only increase to approximately a 0.255, assuming proper maintenance of the system. However, an insulation system with a moisture vapor permeability on day one has the ability to accumulate moisture at a fairly rapid pace over those 10 years. And assuming that it does, you have a thermal K, a conductivity, after 10 years of 1.88, which is significantly greater than the 0.25 that you started off with 10 years previous. What that means is that you're going to lose efficiency in the system that's being insulated. You have the potential for corrosion under the insulation, and the potential of mold and fungal growth in that wet insulation. So having a high insulation system is truly key to having constant and performance over the life cycle. The low thermal K and low water vapor permeability is cell structure. In a cell structure, you have small individual cells that are physically separated from one another by cell walls. This intrinsic barrier to moisture vapor intrusion and constant thermal K without the use of a secondary protective vapor barrier. It also has strong mechanical properties. Cells are physically attached to each other, and it's a natural inhibition of bacterial growth. Bacteria can't spread with the structure because there's physical cell walls preventing it from spreading from one cell to another. It also gives us something that we like to call distributed resistance. If you do a small scratch or tear in the outer skin of an elastomeric closed cell material, there are millions upon millions of other cells with physical cell walls behind that skin to prevent any moisture from penetrating further into the insulation. However, with fibrous insulations that just have an all-surface jacket acting as the vapor barrier, if you have a small tear or rip in the jacket, that's a failure where moisture can then penetrate through and migrate through the rest of the fibrous insulation since there are no barriers preventing it to do so. So the system design roadmap is looking at things from a very high level before getting into your detailed design. These are main aspects of every installation specification that need to be addressed, and just talk about them here before getting into the further details. The first is the specified insulation thickness, probably the most important part of the insulation spec. And into this that you'll be specifying, first thing to look at is the temperature range of the process of the system you'll be insulating. It can be installed on a low temperature line or a medium temperature line. Line cycle for hot gas defrost, and what is the upper temperature limit of that hot gas defrost, because you need to ensure that insulation system overcome that upper temperature limit. You'll look at the ambient conditions of where the insulation will be applied. Is this system going to be installed indoors or outdoors? If it's indoors, is it going to be on the retail space or in the storerooms? In the back storerooms, will they be controlled to the same temperature and relative humidity conditions as the retail space, or will they be untreated in one sense of the word? Any other features in the back storerooms that can contribute to the untreated nature of that area, such as loading dock doors. All of this will affect the thickness of the insulation that needs to be specified in that particular area. For the typical pipe sizes, also known as insulation ID, to be addressed and taken into account. Sizes generally affect the insulation thickness, with large pipes sometimes needing slightly thicker insulation to prevent condensation. Specified insulation thickness, the next aspect you want to look at is the installation procedure. A new store or a retrofit? If you store with new construction, do you use non-slit insulation to eliminate longitudinal seams, slide-on insulation type, and you can further reduce butt seams by using 18-foot coils? Retrofit or repair? Do you want to use a lap seal product, or would you prefer to have it cut and re-glued in the field? These are decisions that need to be made by the insulation specifier. Type is the third that needs to be addressed. Is this to be an exposed or a concealed application? If it's exposed, aesthetics come into play, with black or white, since most installations are available in both. Also, will the insulation be painted? It's important to know if it will be, because then you can use either the black or white color as your base, and then to specify the proper paint to be put on that insulation. Will the insulation be indoors or outdoors? Indoors, a coating or a jacketing will be necessary to protect from UV degradation, and also the thickness will need to be revisited due to different ambient conditions being outside as opposed to inside. Finally, to make sure to address the accessories that go with every insulation system. Accessories include fittings, and you decide whether you will allow to be slid over elbows, small bends, or you want mitered fittings. If you decide on mitered fittings, is it them to be field fabricated, or would you prefer for them to be fabricated in a factory in a controlled environment? After the things, you need to address the hangers and supports. Everyone knows that compression of insulation can lead to failure. So hangers or supports avoid insulating compression of insulation. Will you be saddles or inserts, or will you just be running the insulation on a support rail? One way this will need to be addressed somewhere in the specification. At the high level that we just addressed, that's into the more detailed design of insulation specification. One of the important things you can address is the material type that allow on your project. It's important to state the types and manufacturers of the material that are acceptable to you, and not to just leave open to generic brands. Protect specification by telling people what you want. If you list out specific manufacturers, brands, and types of insulation, it leaves it open to getting the next best thing. Definitely want to specify your physical properties. Don't all products are created equal, and pre-designed by specifying limits. Specify a specific thermal conductivity that you're looking for, and water vapor permeability, and more importantly, your flammability, generally dictated by ASTM E84. To address the specification, the installation. It's important not to assume that all contractors will install up to your expectations, and that you use the resources available to you. The best that we have available is ASTM C1710. This is a comprehensive installation guide that is generic in nature. It's not put together by any specific manufacturer. In fact, all the manufacturers came together to make the generic elastomeric installation specification practices. So it's important to use that and take verb from that to include in the installation portion of your specification. After that, I always recommend that vapor stops be your specification, because if you don't specify them and ask for them, they'll never be installed. So the easiest and best way to keep a small problem from turning into a large one. For those not familiar with vapor stops, they're very easy. What it includes is taking a little bit of contact adhesive, applying that to the pipe and inside diameter of the insulation, and then adhering the insulation to the pipe every 18 feet or so, and also at fittings and any termination points. What this is, segment the insulation into separate compartment's. So if you get one end of a 200-foot run, the water will run down and come out the low point of that insulation run, compartmentalized, where it's easier to identify and repair any failures that may happen. For that, I need to address the fittings. Do they want them? Would you prefer mitered fittings, or are you okay with slide-over fittings? If you prefer mitered fittings, again, specify whether you want field fabricated fittings. So important to address in the specification as well. AFLEX recommends that all seams face downward. This relieves pressure from the weight of the insulation and reduces failures of longitudinal seams possibly popping open. Also important to specify that all seams must be sealed. They seem like common knowledge, but it's not specified. You can't guarantee that it will happen. And address the compression at pipe supports. Whether using saddles, inserts, or rigid supports, compression must be addressed and specified in order to have a fully functional system that will last the lifetime of your refrigeration system. Finally, I want to be able to address alternative refrigeration systems. Ammonia or CO2 or the next alternative that may be coming out. Generally, alternative systems use temperatures and larger pipes, which may increase the thickness of the insulation. So when you're changing your refrigeration system, it's important not to forget to address the insulation that goes on that refrigeration system. It's important to specify a thickness schedule. Don't carry the thickness required in a paragraph somewhere. It's very easy to read and easy to find schedule of thicknesses that you want for different areas of your store in order to ensure that you get exactly what you need on your project. Now, through a couple of do's and don'ts for specification to possibly prevent any mishaps on projects after it's installed. The ones that we see a lot are pipe spacing. It's very important to allow enough spacing around the pipe to accommodate for the insulation and airflow around the insulation after it's been installed. Without proper airflow around insulated pipes, the insulation doesn't work to its best possible. It's important to allow enough space around the pipes for airflow to get around the insulated pipes. If they're too close together, you'll see something like the picture on the right here, where you'll have casual condensation forming. You want to make sure that you specify the proper products for the application. As you can see here, this is a white insulation specified for an outdoor application. I'll start with that all outdoor applications should have, at a minimum, a UV protective coating on the insulation, and even better, a protective jacketing But if neither are specified, then will probably be applied. The black insulation, when installed outdoors, has carbon black in the mix, and carbon black acts as a UV stabilizer, which will prevent UV degradation for a little bit of time. As you can see here, though, the white insulation does not include carbon black production process. This degradation happened over the course of about 4 months. So be aware, and this is a way to hit home, that you need to specify the proper products for your application. K-Flex has an installation guide that lists out our recommended best practices. Some of the points are listed here. Proper pipe preparation. Make sure the system is off and dry and clean. You always push and not pull the tube insulation. By pushing it, you make sure that you don't pull it and make it thinner and spread it out and allow it to be spread out where it could potentially contract and pop open some seams. Make sure that all seams, butts, ends are completely sealed. As we always recommend to install vapor stops, generally at the high end of pipe runs, all termination points, and about every 18 feet or so of straight runs. I recommend to use mitered fittings. They give you a cleaner install. And avoid insulation compression, because that's the fastest way for an insulation system to experience failures. For those, we've got a complete guide, including pictures to how to install our product. As you can see here, for our non-slip tube, we recommend pushing down the pipe, not pulled, and to have the butt joint adhered with contact adhesive and compressed to seal. Self-seal tube, this is always face downward to minimize the pressure on those seams. For fittings, there's a complete guide to show how to create mitered fittings for all types and sizes of piping. On the right side, you can see an incorrect installation where the pipe is pulled around a very sharp elbow here. That causation to thin out around the elbow would lead to condensation and wear and tear on the insulation, and it will eventually fail. I recommend having hangers for the pipe supports. A bearing insulated pipe support at hanger locations prevents insulation compression. On the bottom, you can see pictures of insulation without saddles or supports, just resting on a piece of reinforced bar. It can lead to rub outs and eventually ice buildup and insulation failure, followed by condensation. All things we're trying to avoid with an insulation system. I have a section that shows how to insulate all of the different parts and pieces that you'll find in a refrigeration or piping system, be it valves, Y fittings, strainers, or pipe collars. All this detailed in our installation recommendations. For the installation system, it's always important to perform an installation quality audit. You expect to ensure all areas called out for in the installation specification have been insulated. Check the tools used for compliance to those specified, the type, the inner diameter, and the thickness. Make sure seams have been sealed properly. Make sure there are no tears, cuts, or damage to the outer skin of the insulation, and none of the insulation should be wet. Straight runs, seams should be facing downward to reduce weight on the seam. You should check for the appropriate jacketing, coating, or mastic to outdoor applications. Review hanger and strut areas to be sure the insulation is not compressed. If the system has been turned on, be sure to look for signs of condensation or ice formation, as this is the quickest and easiest way to see a point in the insulation system. Quickly go over the K-Flex refrigeration system offerings. I'll start by that all of our products are third-party tested and certified, in a broad size range up to 2-inch thickness, and the system's approach to the insulation system, not only offering the insulation itself, but also factory-applied PSA, which is pressure-sensitive adhesive, and factory fabricated fittings, a full line of tapes, adhesives, and pre-insulated pipe hangers. All of their standard products are UL Green Guard certified, some including our CLAD WT or NSF, National Sanitation Foundation approved, pre-mutual approved, and most products are made right here in the United States. Features of our products are their closed cell structure, which I discussed earlier, which are resistance to water vapor transmission. They're non-toxic with that UL Green Guard certification I mentioned earlier. ASTM E84 2050 rated, up to 2-inch thickness, to minus 40 degrees Fahrenheit. Total life cycle cost, because we do offer the entire insulation system and not just parts and pieces of it. The most popular product is our insul-tube or Insul-Lock DS. They comply ASTM C534 Type 1 Grade 1. There's the non-slit form for slide-on applications and new construction, or the slit pre-glued form for retrofits. The non-slit form is the picture above, and a pre-slit, pre-glued form is the Insul DS in the lower picture. So you've got the peel and stick adhesive on the longitudinal seam, as well as the peel and stick on the overlap flap, with additional seam security and also prevents water migration through that seam. Thickness are from 3/8 of an inch to 2 inches, all 2050 rated by E84. Available in 3, 6, or 18-foot lengths. Application temperature range is from minus 297 to 220 Fahrenheit. Okay, of this product is 0.245, which equates to the R values listed in the table below. And vapor permeability is 0.01 parms per inch. New Insul-Lock DS, it's available in 1/2, 3/4 inch, 1 inch, 1.5, and 2 inch thicknesses. Our adhesive gives us increased seam security and a temperature rating up to 120 degrees Fahrenheit. You can see our old hot melt adhesive on both seams without an overlap tape. That's been redesigned to have the pressure-sensitive adhesive on the longitudinal seam, along with the overlap PSA closure system, which, as I mentioned, gives us greater seam security there. Next, our jacketing offering. Our K-Flex Clad WT is our NSF-approved system. Again, that's our National Sanitation Foundation. It's approved for deli and food prep areas. The Clad T jacket is a multi-ply laminate alternative to PVC. It applies a PVC backing with aluminum foil and a UV-resistant mylar on the exterior. The product is ASTM E84 2550 rated and, as I mentioned, NSF approved. It's ideal for food prep and washdown areas. Its thickness is 0.012 inches and it's got a water vapor permeance of 0.001 parms. Also at a high emissivity value of 0.8. It's available factory adhered to K-Flex tubes or for field application. Adhered to K-Flex tubes, it does offer a significant labor savings by reducing the amount of labor to having a second step installing the jacket in the field. T-fitting covers and tapes are also available to give a uniform system. And it is available in roll form if it's needed for field application. Of Clad WT is the Clad AL for aluminum coloring. Also apply laminate to metal jacketing. The same laminate applies to the AL with a PC backing, aluminum foil and then a UV-resistant mylar on the exterior. The ideal for outdoor applications, it's resistant to UV, weather events. Thickness as the WT product, as the same water vapor permeance and emissivity. Again, this product is also available factory adhered to K-Flex tubes, which offers a significant labor savings. And fittings and covers and tapes are available to complete the system well. Accessory that K-Flex offers is our K-Fit fittings. The factory-made elbows, T's, and P-traps. These are all made in a controlled environment to the same specifications to make sure you have a uniform fit amongst them. The ASTM C534 Type 1 Grade 1, available in black and white, thicknesses from 3/8 of an inch up to 1.5 inches, all which are E84 2550 rated. The range is our standard insulation offering and the same thermal K of 0.245 and the same water vapor permeability. Heavy fabricated fittings reduces installation time and costs, and also compression fit uniform fittings with watertight seams. Gives us just a better overall installed system and controlled as opposed to factory fittings that may not all be the same size. Our accessories include contact adhesives for quick dry, which are 320 and 620, or slow drying adhesive. We have a low VOC for lead applications, which is our 720, or temperature use adhesive, which is our 420. We've also recently introduced our water-based adhesive, which is 1120 adhesive. We have elastomeric foam tapes, which are either an 1/8 or a 1/4 inch thick by 2 inches wide. We do UV protective coating for outdoor applications, which will need to be reapplied every 2 to 3 years. And insulated pipe supports with bearing rigid core with elastomeric collars, and a 2550 rated of those pipe supports is also available. Some advantages of the K-Flex system include for applications using white tube, reduces the need for painting the insulation to match the surrounding area. 18-foot coils to reduce the number of seams and speed up the installation. Jacketing for outdoor CO2 and food areas. That's K-Flex WT or AL. We offer factory fabricated fittings and of accessories for uniform systems, including tapes, adhesives, and insulated pipe supports. Again, these are some of the advantages of going with one manufacturer for your complete insulation system. Say that K-Flex is a project partner from design to operation. In addition to the products, bring industry expertise. We have active participation in ASHRAE, ASTM, and FMI. We have certified installation appraisers on staff. We offer product training and on-site installation assistance. Specification templates and updates are available as well. We have a very experienced customer service staff. Our product availability is available nationwide through a very broad distribution channel. Documents are all easily accessible at our website of kflexusa.com. And we also have an ISO-Calc thickness calculator available online, which I'll go here in a little more. If you're near, ISO-Calc is a thickness calculator for insulation systems that is very quick and easy to use. It just asks you to input some of the design parameters, mostly your ambient conditions, your temperature, relative humidity, your pipe size, and installation you'll be using, and then calculate the thickness installation required for whatever you get for condensation prevention, or to prevent a specific heat loss, or to get the surface temperature down to a certain. All very quick and easy to use, and ISO-Calc is available for free download from kflexusa.com. If you have any further questions, please feel free to contact your K-Flex representative, and thank you for listening into this webinar. Have a good day.